All right, so in this video, we're going to be looking at what happens to means and standard deviations and shape when you take a set of data and you transform it in some way. Like you add a constant to it or subtract something. So for this example, think for a moment about a test given in class. And if I want to curve that test, I might add a certain amount to each grade, right? Well, what is that adding, 5 points to everybody's score going to do to the average or to the standard deviation or to the shape? So if you've got that in mind, let's look at this. The things that are going to change when I add or subtract a constant, like say add 5 points. The centers will change. You will add the same amount to the mean that you had before and the median. And the locations will change. The percentiles and the quartiles will change. All right, so the actual values at the 25th percentile or the 28th percentile will be changed because you've added something to all the values. But what is going to stay the same is the shape. So if it was a symmetric distribution, it would still be a symmetric distribution. It would just be moved over 5 units or whatever. Now, the spread would stay the same as well. Either if I was using IQR, standard deviation, or range, those would not change. It's still how spread out is the data, and if every piece of data has been changed by adding 5 points, the spread of the data hasn't really changed. We'll model this in class with a set of data, but for now, get this in your notes. But what happens though if I take test scores and I decide to multiply them by 1.5? I'm not adding, but I'm multiplying, or the same idea is going to happen if I divided by something. So the things that are going to change, very much what we've done before. The centers will change. What the mean is and the median will be changed by the same amount you multiplied by. The locations will change, like percentiles and quartiles. It will also change. Now, shape will stay the same. It's not going to change our shape at all, but it will change our spread. Okay, IQR, standard deviation, and range will be changed by the same factor that we multiplied or divided by. All right, but shape, again, will not change. It's going to retain the shape of the original no matter if we add, subtract, multiply, or divide anything to it. All right, now let me try walking you through an example. In 2010, taxicabs in New York charged an initial fee of $2.50 plus $2 per mile. In equation form, it looks like this. Fare equals $2.50 plus 2 times the miles. At the end of the month, a businessman collects all of his taxicab receipts and analyzes the distribution of fares. The distribution was skewed to the right with a mean of 15.45 and a standard deviation of 10.2. What are the mean and the standard deviation of the lengths of his cab rides in miles? So we're not talking about how much did he pay, but what is the standard deviation of miles? So we need to start with what we know. We know the equation they gave us. The fare was calculated by doing base of $2.50 and then $2 per mile. So if I want to get it to miles, I need to solve this algebraically for miles. So I'm going to subtract the $2.50, then I'm going to divide by 2. This gives me miles. So I'm going to then use these transformations to help me determine what would be the mean and the standard deviation for miles. So notice I have a value that's being subtracted and I have a value that's being divided. So when I do mean, I remember what it said on the previous slide. The mean gets changed whether I'm adding, subtracting, multiplying, or dividing. That always changes by whatever factor. So I'm going to have to subtract 250 from the mean fare, and I'm going to have to divide by 2 for the mean fare. So I'm going to subtract the 250 and I divide. So that gives me a mean of 6.47 miles that was on his taxicab rides. But when I need standard deviation, if you recall, standard deviation is not affected when you are adding or subtracting a value. So this subtracting 250 does not affect the standard deviation. However, dividing by 2 will affect our standard deviation. So to find my standard deviation, I'm going to take the original standard deviation he gave us and divide it by 2. So the standard deviation on the length of his cab rides is 5.1 miles. So when you're looking at the transformations, you've got to consider, am I changing a mean or a standard deviation? And then pull in the correct components and factors needed. Now, if the businessman standardized all the fares, that means he converted them all to z-scores. What would be the shape, the center, and the spread of the distribution? Okay, so let's think about what changes and when. The shape, if you remember in our charts, the shape never changed, whether we added, subtracted, multiplied, or divide. So the z-score would be the same as the original, and the original was right skewed in this case. So the shape will always be the same as the original. The center, we subtract by the mean. We had to subtract each value by 15.45. It reduces the mean to 0, because the mean minus the mean is 0. Dividing each value by 1020 will also divide the new mean by 1020, but 0 divided by anything is still going to be 0. So my center will always be a 0. When you've standardized scores, the center is always 0. And then lastly, the spread. The subtracting doesn't affect the spread. However, when you divide each value by the standard deviation, it would make the standard deviation equal to 1, because something divided by itself is always 1. So what does this tell us? Anytime you've standardized a set of data, fares or whatever, the standard deviation will always equal 1. Just like the center, the mean will always be 0. And the shape will always be the same shape as the original set of data. So, standardized distributions, that means they've all been converted to z-scores. The average or the mean of them all would be 0, and the standard deviation is always 1, always, always, always.